Okay, this video is about simple nested similar triangles. Now remember, similar is one of the ways to know that you're in the topic where if you double one thing, you double another. So if I don't know, 5 became 10 and I asked you what would happen to 3, well 3 would become 6. If it's doubling there, it's doubling there. Doubling is just an example. If 5 became 0.5, that would be dividing by 10, so do the same to 6. Now, triangles are a very famous area for similarity questions, because it's really easy for us to guarantee to you that they're similar. What we do is we just give you triangles where the angles are certain to be the same. So if I do some triangles like this, if I tell you that that's the same as that, you basically show that those triangles are similar because they have the same angles. That's equal to that, that's given. That's equal to that because of vertically opposite angles from year 7, which means they're basically the same triangle, because whatever that and that are, you just subtract it from 180, you get this. If those two angles are subtracted from 180 getting the dot there, then they're also going to get the dot there because it's basically the same numbers. So that's similar triangles. So if that was a 2 becoming a 4 and that was a 3, then that would have to be a 6. You have to be careful. The 3 is opposite the cross, therefore it is the side opposite the cross over here that will become a 6. And if that was a 5, then that would have to become a 10. Okay? So now that's what similar triangles are all about. I'm now going to tell you about a very famous situation where triangles are similar. It's when triangles are nested. In other words, one triangle is inside another. Now my strong advice for this is to draw the triangles out separately. There's the small triangle, there's the big triangle that it used to be part of, and then copy the information across. So if that was a 2 and that was a 3, and that was a 4 and that was an X, copying across, that's a 2 and a 4, copying across, that is a 5 and an X. Okay? So, how can I be sure that these triangles are similar? Well, I can't yet, but if I'm told that they're parallel lines, then that's the same as that because it's physically the same angle. Both those come from up here. That's got to be the same as that because of the corresponding angle of the year 7F business. So that's got to be equal to that, which means we're done. Okay, so what can I spot here? I see a 2 becoming a 5. How does a 2 to become a 5? Do it in 2 stages. First divide by 2, then times by 5. Do that to 2, to 4. So therefore, X has to be 10. Okay, so that's simple nested similar triangles. Basically what I want you to do is practice just copying them out into 2 separate triangles and spotting the doubling or whatever.